Hey guys, so today we got a quick little lesson over average rate of change, all right? Average rate of change. Okay, and what this is going to do is it's going to help us lead into our derivatives, okay? We're going to start that, I think, tomorrow or 2 days from now. Either way, you'll see the video up and you'll know when to watch it based on the calendar. So, we're going to dive right in. Today it's just some example problems, getting our feet wet. Okay, so the big thing to remember is kind of remember slope. I want to talk about slope because that is what average rate of change is. It's the slope of something. Okay, so remember slope equals our y2 minus our y1 over our x2 minus our x1. Okay, or we could think about it in terms of functions, right? The function of x2 minus the function of x1 over x2 minus x1. Okay, remember y is like the same thing. It's the result from the function. So, first example we're going to go into today is we're going to find the average rate of change for a given function in the interval. So, for the first one, okay, we're going to have the function f of x equals 3x minus 7. And we want to know and we want to know the rate of change from the interval x equals 5 to x equals 9. Okay? So the first thing we can do is kind of plug in all this information we have in. We know that we can kind of figure out that our slope, or we can find out our slope first. That's the first thing we're going to do. We're going to plug in our f of x1 or f of x2, all that stuff, and we're going to get our slope. So the first thing we got to do is let's plug in the two ends of our variable. So we're going to have our f of 9 and our f of 5. Okay, so if we have f of 9, that's going to be 3, 9 minus 7, which is going to equal 20. And for our f of 5, we're going to get 3 times 5 minus 7, and it's going to equal 8. Okay, so now we have our two x's, right? They gave us our x from 5 to 9. We have our two results from plugging in those x's, our 20 and our 8. So now we can go in there and find our slope and find, right? Remember what slope is? It's the average rate of change. So now we take those formulas I wrote at the top. So we have 20 minus 8 over 9 minus 5. 12 over 4, which equals 3. So our average rate of change is 3 based on that function. Okay, and as you can see, this function, it's linear, right? That's a flat line, so that's pretty easy. We just found the slope, which happens to just already be there for us. Okay, as we go, things will get a little bit more complicated, don't you worry. Let's go on to the next one. Okay, 2. A little too far. This time we have the function f of x equals negative x squared minus 3x plus 1 from x equals negative 1 to x equals 4. So just like last time, we're going to just start plugging in those x values into our function. So we have our f of 4, we have our f of negative 1. First things first, so we have our negative 4, just start plugging and chugging. Sorry, my handwriting's getting a little crazy right now. So equal negative 16 minus 12 plus 1. Okay, it's going to equal negative 27. Okay, those are 4s I'm plugging in if you can't tell. My 4s get a little sloppy. Alright, going on down to f of negative 1. We're going to have negative 1 squared minus 3 negative 1 plus 1 equals negative 1 plus 3 plus 1 equals 3. Okay. So now we have our all the components we need to find our average. Right? We're just using those formulas up at the top to find our average rate of change. So we have our, right, if you guys don't, I'll keep that right there. If you guys don't remember, all I'm doing is this. F of 4 minus f of negative 1 over 4 minus negative 1. Same thing as negative 27 minus 3 over 4 minus negative 1, which equals negative 30 over 5, which equals negative 6. Okay? We're just using that slope equation every single time to find our average rate of change. This should be a lot of review for you guys, actually. Okay, next problem. 3. 3's got a couple different parts to it. So we're going to go through that. So 3, the first one, we're using this equation for all of them. So we're going to use this f of x for part A, B, and C. Okay, so for part A, they want it to be from x equals 5 to x equals 9. So again, we're doing our big old equations. We got our f of 9. We got our f of 5. So if we start plugging and chugging those in, 2 9 squared minus 3 9 plus 1 equals 162 minus 27 plus 1 equals 136. Okay, so I got 136. For our f of 5, you get 2 times 5. 3 times 5 plus 1, which equals 50 minus 15 plus 1 equals just 36. All right. So now we got all our pieces. We can plug it into our average rate of change formula. We're going to have all our 136 minus 36 over 9 minus 5, which gives you 100 over 4, or 25. Okay, average rate of change is 25. Now let's look at B. So now we're going to have B. B is asking us to do it from x equals 5. Here, and you know what? I'm going to write this over again. Hold on. From x equals 5 to x equals 5 plus delta x. Okay? Remember, guys, delta x is just like another variable that we're using in this case. Okay, don't let it freak you out. We did this before. We're going to kind of do that stuff again that we touched on in, what was that? 1.2, I'm pretty sure. So remember, our equation is also f of x equals 2x squared minus 3x plus 1. Okay, that's just from up top. So think about it this way. Let's just plug this straight into our average rate of change formula to start and look at it. So we're going to have our f of 5 plus delta x minus f of 5 all over 5 plus delta x minus 5. Okay, well, just from looking at that to start, you can cancel those out. Okay, so now when we start plugging on in, we're going to start plugging this into our equation. So we have our, we're going to start plugging our 5 plus delta x into our equation. So we are going to have 2 times 5 plus delta x squared minus 3 5 plus delta x plus 1 minus, now we're doing it for the 5. Here, I should, you know what? Forget that. I'm going to write it all underneath. I'm going to write this neat for you guys. Okay. 2 5 plus delta x squared plus 1. Okay, so that's this part we just did. Now we're going to do this part. Minus 2 5 squared minus 3 5 plus 1. Oh, that's like that. That. Okay, and remember, that's all over delta x. Okay, so now the next line. Okay, we're going to expand this all out. Expand this all out so we can start canceling some stuff out. That's the key. So I got 2 25 plus 10 delta x plus delta x squared minus 15 minus 3 delta x plus 1 minus 50 plus 15 minus 1. Okay, now you can see we can start canceling out our 1s, cancel out our 15s. I think that's it. Oh, and you can't forget this is all over delta x. All divided by delta x. So the next line. So what we're left with 50. Or because now we're distributing that too. So we're left with 50 plus 20 delta x plus 2 delta x squared minus 3 delta x minus 50 divided by delta x, as always. Okay, from here all I can see is the 50s canceling. Okay, and if you look at, see, now we can set this up a little bit cleaner. So I'm going to set this next line up for you guys. All right, clean it up. What we have left after we cancel out those 50s is we have that 20 delta x plus 2 delta x squared minus 3 delta x all over delta x. So if you think about it, the numerator, we can pull a delta x out front. Then we're left with 20 plus 2 delta x, because that was a squared, minus 3 all over delta x. Those guys cancel, just like we were doing in those proofs before. Okay, your result when you simplify that all out, it's going to be 17 plus 2 delta x. All right, so the average rate of change in that range. Okay. We're moving on down to our last part, C. All right, and C, what they're asking us is they're saying we want to go from x, remember same function, x, to x plus delta x. Okay, now we've taken numbers out of that completely. So again, this is what it looks like. We're plugging this. And if you guys remember, actually, this is the difference quotient. Okay, it's our f of x plus delta x minus f of x all over our x plus delta x minus x. Okay, and again, look, boom, boom, cancel out. So, from here, we have our equation again that we're just plugging in. Our 2x plus delta x squared minus 3x plus delta x plus 1 minus 2x squared minus 3x plus 1 divided by delta x. Whew, that's it. Okay. Now from here, let's simplify a little bit. Let's expand it out. I got 2x squared plus 2x delta x plus delta x squared minus 3x minus 3 delta x plus 1 minus 2x squared plus 3x, I think that's a minus 1 all over delta x. Okay, from here, we can get rid of these ones. See ya. We can get rid of our 3x's. And so this is what we're left with at the next line. We're left with, okay, now we're distributing this 2. We're going to distribute this 2. You're going to get 2x squared plus 4x delta x plus 2 delta x squared minus 3 delta x minus 2x squared all divided by delta x. Now, we can cancel out a little bit more like these 2x squared. See ya. And what we're left with is terms that only have delta x, so we're going to pull that out front. Right, I'm pulling this delta x out of my numerator. You get that delta x right there. Cancel it out. You're left with 4x minus 3 plus 2 delta x. All right. Now, if you think about this, for this difference quotient, what we can do is we could actually go back and use this equation and solve anything we want. Oop. So, if we go back, remember x1, that original one was x was 5 to 9, right? So our delta x equals 4. So if we plug that into our equation, our 4, and we want to use our x1 term, which is 5, so we have 4, 5 minus 3. Our delta x is 4, so 2 times 4 is 8. You get 25. Hold up a second. What did we get up here? For 3, negative 1? We got 25 for the rate of change. Okay? So when you find, so look, this function we found is a universal function. Let's do the next one. Let's see. For the next one, right, that was 2 to 3. So for 2 to 3, right, our delta x equals 1. So we plug in 4 times our x1, which is 2. Okay, minus 3 plus 2 times our delta x, which is 1, so that's 2. Get 7. Okay, let's do another one. If you have 10 to, if you have x is going to be from 10 to 10.1. Okay, our delta x is only 0.1. So we plug it into our equation. 4 times x1, which is 10, minus 3 plus 2 times our delta x, which is 0.1, so that's going to be 0.2. You get 37.2. Okay. So like I said, this is just a step into what we're going to be doing in 2.1. It's to get you used to using this different quotient and understanding how it works. Okay. We're measuring the average rate of change between 2 points, and we're coming up with an equation that allows us to, by using the different quotient, to find that rate of change much quicker. Okay? Let me know if you guys have any questions. And again, especially with this calculus stuff, it's a great opportunity to look up some stuff on your own. Okay? There's a lot of different ways of looking at this. I suggest you also watch some videos besides mine.